Hi everyone, good um, good day, and welcome to our next topic on our Earth Science class. So this time we will be discussing about Earth, the systems, and subsystems of the Earth. Now, Earth is a complex of interacting physical, chemical, and biological processes and provides a natural laboratory whose experiments have been running since the beginning of time. So the Earth system is often represented by interlinking, interacting spheres of processes and phenomena. So if we observe, the Earth is interacting with each other, meaning the aspects, the processes, and even the system of the Earth or the systems of the Earth are interlinking with each other. That's why every system, every part, every aspect of the Earth is really important. Now, there are four spheres of the Earth. Because, of course, as I've mentioned, it is a system. A system is a collection of interdependent parts enclosed within a defined boundary. So, when we say a system, and within that boundary of the Earth is a collection of four interdependent parts called the spheres. And the Earth spheres include the following. We have the atmosphere, we have the geosphere, we have the hydrosphere, and we have the biosphere. Now, a sphere, on the other hand, is like a ball, or it is a series of three-dimensional circles. So when we say a sphere in a mathematical concept. However, we have the four main spheres of the Earth interacting, interlinking with each other in order to provide life here on Earth. So we have geo, or yeah, let's have first the prefixes of the systems. So we have geo, which means rock. We have hydro, which means water. We have atmo, which means air, and we have bio, which means life. So these four aspects of the earth are actually interconnected with each other. One needs the other, or one cannot function, or the four cannot function without the help of the other aspects. So that's why the four aspects, the four parts of the earth are interlinking, interacting with each other. So the geosphere is the sphere of rock that is the earth. Now, we will just review your previous discussion in high school about the systems of the earth. So we will discuss much of the systems or the spheres of the earth in the next learning package or in the next week. Now, this includes the rock on the surface and the interior when we say the geosphere. Of course, I know you're familiar with the layers of the earth. We have the crust, the upper mantle, the lower mantle, the inner core, and we have the outer core. So let's start with the crust. So just to provide a brief background of the following layers of the earth, we have the crust, which is the layer that you live on. So it is the most widely studied and understood. So the crust is made of the lightest material or lightest matter, and the core consists of heavy metals. So we have here, um, if we look into the illustration of the layers of the earth, we can say that um, the layers having differentiation, meaning one layer is different from the other. So the inner core, even the inner core and the outer core with different composition, with different chemical composition, because the outer core is in the liquid state while the inner core is in the solid state. So you can say that there is, or we can say that the layers of the earth compose of different elements and chemicals and compounds. And the crust, the earth's crust is like the skin of an apple. These are very thin in comparison to the other three layers. So this is the outermost layer of the earth. So next to the crust, we have the mantle. So the mantle is the largest layer of the earth. So it is made of hot, dense rock. The rock in the mantle flows like asphalt because of the temperature or the differences in temperature found in the mantle. And mantle, the movement of the mantle create the movement of the Earth's plates. So we have here the movement of the plate tectonics are actually being observable in the mantle, and we have the crust layer. And we have also the core. So the core of the Earth is much like a ball of very hot metals. So the inner core is surrounded by a fluid iron, while the outer core is actually the inner core is composed primarily of the solid iron and nickel, while the outer core, which has been confirmed to be liquid iron and nickel. So in this layer, we can somehow say right away that they have different behavior, or the chemical composition would have different behaviors for the reason that one is liquid, the other one is solid. So in terms of the state, one will have a different behavior, chemical behavior to the other. And next to the geosphere, we have the hydrosphere. So the hydrosphere is the sphere of water that covers 70% of the earth. So of course, water is needed by almost all organisms here on earth. In the hydrosphere is made up of all the salt water and fresh water on earth. So we have the ocean portion and we have the freshwater portion of the earth. So the salt water in the oceans and seas, while the fresh water in the lakes, the rivers and streams, and the frozen water on earth. So those are actually um, the division. One is the saltwater portion, including the oceans and seas, and one is the freshwater portion, including the lakes, the rivers, and the streams, and even the frozen water on Earth, specifically the North Pole, the South Pole, and the temperate regions. So those ice and ice caps, snows, so those are still part of the freshwater portion of the Earth. Now, all liquid water runs downhill. Of course, there is what we call surface runoff. And well, it starts as fresh water in the high areas and runs downhill until it reaches the ocean. It's really obvious, it's self-explanatory that all fresh water in higher areas will run down into the ocean. Even like the rivers, so the end point of the rivers are actually the ocean. So now, one of the important biogeochemical cycles here on Earth, or one of the biogeochemical cycles, we have the hydrological cycle, or in short, the water cycle. So the hydrological cycle or the water cycle involves the water portion of the Earth. So that's why we are, aside from the other biogeochemical cycles, we are being affected primarily with the hydrological cycle. So what is hydrological cycle or water cycle? The hydrological cycle is the system which describes the distribution and movement of water between the earth and its atmosphere. So the model involves the continual circulation of water between the oceans, the atmosphere, the vegetation, and the land. Well, of course, there is a continual circulation for the reason that it's a cycle. When we say a cycle, no ending, no start, right? It's continuous. So let's have the different parts of the hydrological cycle or the water cycle. Of course, since it's a cycle, we will start with um, one portion to the other. So we have evaporation. So ano yung evaporation? I know you're familiar with evaporation for the reason this is the conversion of water or liquid into gas. So it's turning water into water vapor. So when we say evaporation, the solar energy powers the cycle because the main energy of the earth is really coming from the sun. So when the sun hits at the earth, of course, it will affect the hydrological cycle of the earth. So the heat energy from the sun causes evaporation from water surfaces such as rivers, lakes, and oceans, but primarily um, bigger component of water, evaporated water coming from the oceans. For the reason that it's proportional, meaning malaki kasi ang ocean, so that's why sila rin yung malaking reserve ng water to be evaporated. So we have also in the process, aside sa evaporation, um, we have what we call the specific evapotranspiration and we have transpiration from plants. So transpiration is essentially evaporation of water from plant leaves. So to be specific, we call it as the evapotranspiration. So it's the water lost to the atmosphere from plants and water surfaces, including the soil. So meaning, if you observe, or if you're fond of like observing plants during morning, you can see a dew, or you can see a droplet of water in the leaf margin. So this actually because of the uh, somehow the process capillary action in plants. And later in the middle of the day, you will observe that, or you cannot observe anymore the dew or the water droplet. Why? Because of evaporation. So sun hits up the earth, resulting to the evaporation of water, not just from the sources, the water sources, but also in the other parts of the earth, like plants and soil. Next, we have the condensation. So condensation, this is the process of what? Converting gas into what? So converting gas into liquid, right? Gas into liquid because the warm, moist air containing water vapor rises, and as it cools, condensation takes place to form clouds. Now, how the clouds are actually formed? I know you're very familiar of the formation of the clouds, or any idea about the formation of the clouds. So again, as I've mentioned, that when we say condensation, it's the vapor state to a denser liquid or solid state. But in terms of hydrological cycle, very observable from the gas state, from the vapor state to a liquid state. So, I know that you are familiar that clouds form when moist, warm, rising air cools and expands in the atmosphere. Of course, that is why the warm air is somehow lighter than the cool air. So when the warm air rise up, well, of course, it will affect the atmosphere. It will be responsible for the cooling and expansion in the atmosphere. And, well, of course, if the clouds, so from water vapor into water droplets in the atmosphere, and because of the cool air and the moving air in the atmosphere, when the clouds cannot handle much of the droplets, then it will what? Go back into the earth. So in the form of precipitation. So wind energy may move clouds over land surfaces where precipitation occurs. It's either as a rain or snow depending on the altitude, depending on the location, depending on the region. Because of course, those areas with what we call temperate regions or tropical regions, they will have the different types of precipitation. Tropical regions will receive rain, while temperate regions will receive snow, or we have ice, lakes. So depending on the altitude, that's precipitation. Because there are different types of precipitation. We have rain, snow, we have flakes, we have hails. So those are types of precipitation. Now, in the process of precipitation, we have what we call the stem flow. Stem flow meaning it's the precipitation flows down stems and branches to the ground, specifically on plants. So when the rain, of course, reaches the leaves, or when the rain reaches the leaves, it will flow down into the stems, going back into the ground. So still it's somehow water will return back to plants. Diba sabi ko kanina, during evaporation, the water from the plants will actually evaporated. But during precipitation also, the water or the rain will go down, meaning will flow into the stem, and then go into the branches, and then go into the ground. And we have also what we call the throw flow. So in the illustration, you can see the yellow one. So it's the rate at which precipitation flows through the branches. So it's the rate. So gaano kabilis yung flow ng rain ng precipitation doon sa puno or doon sa plants. Then we have also part of the cycle, we have the runoff or the overland flow. Of course, we have higher elevations, we have a higher area. So the rainwater flows either over the ground, such as runoff, into the rivers and back to the ocean. Or it could be, there will be what we call infiltration, meaning the rainwater will go down into the underground, meaning it will form the underground water. So aside from those flowing on the surface, we have also water infiltrating the ground. So those water running on the surfaces will go to the bodies of water, such as the rivers, the streams, and lakes, and even oceans. So as what I have mentioned, we have the infiltration or the groundwater flow. So infiltrates downwards through the soil and rocks, where it is returned to the oceans through groundwater flow. So ito yung source, yung water na pumupunta sa underground or sa groundwater natin. Yun yung source ng tubig na iniinom natin. So we have here in the illustration. So of course, going to the river, yung nag-surface runoff, going into the river, and then yung iba, pumupunta under the, or underground. Next, another sphere of the earth, we have the atmosphere. So atmosphere is the sphere of the air that surrounds the earth. It's actually the gaseous blanket of the earth. So it's the gaseous blanket of the earth encompassing all parts of the earth. And there are different layers of the atmosphere. So we have what we call the troposphere, the stratosphere, the mesosphere, the thermosphere, and we have the exosphere. So later on we will discuss where can we find satellites, where can we find those airplanes, sang parte sila ng atmosphere makita. Are they part of the atmosphere or are they still part of the Earth? Now, in the dry air, or in terms of decomposition, nitrogen is the dominant gas, the dominant gas in the atmosphere, followed by oxygen, then argon, carbon dioxide, and we have others, including neon, helium, krypton, hydrogen, xenon, uh, ozone, and we have the radon. So these are some of the elements. These are some of the substances found in the atmosphere. So the layers of the Earth, as I mentioned, we have troposphere, stratosphere, mesosphere, and we have the thermosphere. So of course, specific layer would have specific characteristics. So the troposphere is the lowest and the thinnest layer among the layers of the atmosphere. So it's 16 kilometers at equator or 8 kilometers at poles. And of course, composing 90% of the atmosphere's mass. So temperature decreases with altitude and approximately nagdi-decrease siya 6 degrees Celsius per kilometer. So the top of the troposphere averages negative 50 degree Celsius. So in the troposphere, this is where the weather occurs, and the boundary between the troposphere and the stratosphere is called the tropopause. So in the troposphere, ito yung component dito, or ito yung portion affecting the weather of the Earth. So the changes in the troposphere would affect the weather of the Earth. Next, we have another layer. We have the stratosphere. The stratosphere is the second layer of the atmosphere. It extends from 10 kilometer to 50 kilometer, or 10 kilometers to 50 kilometers above the ground. So it's actually less dense, so less dense than water vapor. And temperature increases with altitude in this portion. So almost no weather occurrence. It contains a high level of ozone, or this is where the ozone layer is located. So the upper boundary is called the stratopause. So the upper boundary of the stratosphere is the stratopause. And for your information, this is where the jet or the jet aircraft and weather balloons fly. Hanggang dito lang yan sila. Because if lumampas yan sila, it would affect now the aircraft. So hanggang dito lang yan sa stratosphere, yung jet aircraft and mga weather balloons. Alright, so here we have here the illustration about the illustration on the layers of the atmosphere. Next layer we have the mesosphere. So the mesosphere is the layer, according to some scientists, this is the layer hard to study. It extends to almost 80 kilometers high. Gases are less dense, and the temperature decreases as the altitude increases. So gases in this layer absorbs very little UV radiation. And according to scientists, or scientists do not know that meteors burn up in this layer. So when the meteors passing through the mesosphere of the Earth, then it will burn up. So in the mesosphere. Next, we go also the thermosphere. So thermosphere above the mesosphere and extends to almost 600 kilometers high. So in the thermosphere, temperature increases with altitude, readily absorbs solar radiation, and the temperature can go as high as 1500 degrees Celsius. So in this portion, it reflects radio waves. In fact, this is where the space shuttles flew and where the International Space Station orbits Earth. So hanggang dito lang yan sila. It will not go over the part of the thermosphere. So yung mga space shuttles natin, hanggang dyan lang yan. Yung mga international space stations or satellites orbiting the Earth. Not natural satellites, but those man-made satellites. So in this portion also, we can see that. I know you're familiar with this picture. So where we can see the aurora. So we have the aurora borealis and the aurora australis. So we have two different auroras. So the aurora borealis, that's actually the northern lights, while the aurora australis, that's the southern lights. Again, aurora borealis, that's northern lights. Aurora australis, that's actually the southern lights. Aurora can, or aurora are actually collisions between electrically charged particles from the sun that enter the Earth's atmosphere. So yung mga electrically charged particles and the composition of the atmosphere will result to the different colors that you can see when you observe auroras. So because of the electrically charged and the components, the particles present in the Earth's atmosphere. Now we have also the exosphere. So the exosphere is the interface between the Earth and the space. So atoms and molecules can escape to space through the exosphere. And we have, or next, we have the very important sphere of the Earth, which is the biosphere. Biosphere is the sphere of living things on Earth. This is the life portion of the Earth, or the spheres that sustains, or the sphere that sustains life. But however, without the other spheres, biosphere will not function well. Life on Earth will not function well. Alright. So of course, in the biosphere, this includes all the plants, animals, fungus, protists, bacteria on Earth. And the spheres systems are endlessly interacting. The geosphere, the hydrosphere, the atmosphere, the biosphere, in order to sustain life, in order to provide life here on Earth. So can you think of ways that they interact? Of course, you're very familiar. One example, we have the biogeochemical cycles, including the water cycle, which is very important in sustaining life here on Earth. So the system interactions would have actually result, o yung mga interaction ng mga system would also affect the changes, the phenomena here on Earth, the natural phenomena here on Earth. So we have hurricanes, so sweep across the ocean and onto the land and damaging the dwellings of the people who live the coast. So in that analogy, hurricanes actually part of the atmosphere, sweeping the ocean, so that's part of the hydrosphere, and damaging the land, that's the geosphere, and even damaging people, damaging plants, animals, and humans, which are part of the biosphere. So the system interactions, as I've mentioned, also presented with natural phenomena. So, like for example, we have earthquakes. So, earthquakes can damage buildings, which may kill people, that's biosphere, as well as cause fires, which release gases into the air. So, it's atmosphere. So, if you can see the analogy, all the systems are interlinking, all the systems are interacting with each other. So earthquakes in the ocean may cause tsunami, which is part of the hydrosphere, which can eventually hit land and kill both animals and people, and that's part of the sphere. So you can see the analogy in terms of like natural phenomena that the systems of the earth would really be affected by the natural phenomena. And those natural phenomena are very common. So as what I have mentioned, it's natural. It's commonly observable, commonly happening here on Earth. So that's why we have common natural hazards and disasters. So just to define when we say natural hazards and disasters, so natural hazard, it is a natural event that has the potential to harm people and their property. On the other hand, a natural disaster is the realization and impacts of a natural hazard, including deaths, injuries, disruption, and damage. So yun yung difference ng dalawa. Yung natural hazard is actually a natural event. Yung disasters, ito yung nakikreate ng natural hazard. It's actually the impacts of the natural hazard. Nagiging epekto ng natural hazard yung disasters. So we have the global natural hazards. Of course, we have this one because of the interlinking systems of the earth. And some of them are natural, some could be what? Some would have human intervention. So global natural hazards including floods, severe windstorms, earthquakes, tsunamis, droughts, volcanic eruptions, landslides, and wildfires. So these are the common natural hazards. And we have also the Pacific Ring of Fire hazards. And we are part of the Pacific Ring of Fire. So the Ring of Fire is a major area in the basin of the Pacific Ocean where many earthquakes and volcanic eruptions occur. So that's why hindi na tayo magtaka that Philippines is actually, or Philippines always experiencing earthquakes and volcanic eruptions for the reason that we belong to the Pacific Ring of Fire. We belong to the basin of the Pacific Ocean where many earthquakes and volcanic eruptions occur. Why? Because in the Pacific Ring of Fire, there is what we call subduction portion, meaning this is the area where subduction commonly observable. So when we say subduction, it happens when tectonic plates shift and one plate is shoved under the another, meaning when one plate collided with another plate, so resulting to the subduction of one portion. So kaya nagkaroon ng movement, nagkaroon ng tectonics, plate tectonics. Then we have also Asia's hazards like China. So common na mga hazards doon sa China, we have floods, earthquakes, typhoons, eruptions, landslides, droughts, environmental impacts. We have also in India, we have floods, earthquakes, cyclones, landslides, and droughts. Then we have Japan, floods, earthquakes, tsunamis, typhoons, volcanic eruptions, landslides, and droughts. So very common, lalo na sa mga tinatawag na archipelago, yung tsunamis and typhoons, lalo na sa Philippines because we are an archipelago, meaning napapalibutan tayo ng bodies of water. So kaya very common sa atin yung typhoons and tsunamis. Now, we have, or let's have now the environmental impacts. So of course, the environmental impacts, including like atmosphere and climate issues. And I know you've been hearing a lot about global warming, the ozone hole, and air pollution. So these are atmosphere and climate issues. These are system issues of the earth. So what is one of the issues is actually the greenhouse effect. So what is this greenhouse effect? It is heat from the sun being trapped by the gases in our atmosphere, and a greenhouse effect may relate to the closed car on a cold sunny day in winter. Now, sir, do you think the greenhouse effect is good, or do you think the greenhouse effect would have an advantage? Yes, of course. The greenhouse effect is a good thing. It allows for life on Earth. Meaning, greenhouse effect is responsible for the warming of the Earth. Meaning, it's the responsible for the constant warming of the Earth. So the greenhouse effect is a term that describes how natural gases in the Earth's atmosphere reduce the amount of heat escaping from the Earth into the atmosphere. So the more of these gases there are, the more the Earth heats up. So ito yung sila yung responsible for the warming, the heating of the Earth, yung greenhouse gases. So what are the greenhouse gases? So there are gases in the atmosphere that trapped and radiate heat from the sun. So we have the major gases. I know you're familiar of those gases. We have the water vapor, the carbon dioxide, the chlorofluorocarbons or the CFCs, the methane, and the nitrous oxide. So we have one important greenhouse gas. So one of the important greenhouse gases, I mean. So we have water vapor, which is one of the most important greenhouse gases, and one whose levels in the atmosphere are not directly affected by human activity. Next, we have the carbon dioxide. Carbon dioxide is the greenhouse gas that is most directly affected by human activity, and it only makes up 0.04% of our atmosphere. So that's why somehow we are contributing to the amount of carbon dioxide in the atmosphere. So yun na nga, sabi ko kanina that there are natural phenomena with human interventions. So with human interventions, this greenhouse gas will become worse. Then methane released by warming oceans and defrosting soil of the tundra and can also raise global temperatures. So what is global warming? I know you've been hearing about global warming. So when you say global warming, this is an increase in the temperature of Earth's atmosphere. It's also of the greenhouse gases. Simply means that the Earth is getting hotter because of the greenhouse gases. So the scientific community, the scientists believe that climate like global warming have occurred throughout history and will continue to occur in the future. That's why there are arguments, there are debates that global warming is natural, global warming is man-made. So there are pro-natural and there are pro-man-made. But somehow we can say that yes, it's natural, but because of human interventions, because of human effects, then we can say that partly global warming is also man-made. So scientists have spent decades figuring out what is the cause, what is causing global warming. Kasi maraming debates na nangyayari, maraming proposals, maraming propositions if it's man-made or natural, because they believed that warming is natural to Earth, or we are always experiencing warming here on Earth. So it's not new according to those uh, pro-natural concept of the global warming. Now, historically, global warming or two circumstances have caused global climate change. Kaya nasabi ng iba na it's natural because of, based on history, that there is an increase in the solar output of the sun, resulting to the warming of the earth. So isa yun sa mga reasons why they consider global warming as natural, because there is a natural increase in the solar output of the sun. And we have also common natural phenomena, ejecting gases, greenhouse gases. We have the volcanic eruptions. So ito yung nakaka-apekto sa global warming. And evidences of global warming nowadays. So we have the melting of the glaciers in Greenland, North America, in South America, and Europe. Very observable yung effect ng global warming nowadays. Kaya nga, very observable din that there are floodings all over the earth. For the reason that we have the rising of water level in the oceans because of the melting of the ice, the glaciers in different temperate parts of the earth. So we have ice shelves which are breaking off in the Antarctic Peninsula. However, the interior of Antarctica is cooling. But because of global warming, yung ice shelves in Antarctic Peninsula nagbe-break down, nagbe-break off. Aside from glaciers and ice shelves, we have the polar pack ice in the Arctic Circle, which is forming later in the fall and melting earlier in the spring. So pag nag-melt to is sila, ang nangyayari, it will result to the rising of the water level, meaning it will result to the um, additional water component in the oceans. So kaya kung continuous yung pag-ulan, common or observable na yung pagkakaroon ng baha. Because it's inevitable nowadays for the reason that we experience global warming, we experience melting of those glaciers and ice shelves, polar pack ice. So, of course, I will be showing you the result. So this is the ice shelves in Antarctica and the polar pack ice, Arctic Circle. So if you observe, nung dati pa, these areas are actually covered with thick ice. But because of global warming, try to observe the ice there, the ice shelves, the polar pack ice are melting. So when they are melting, it will add up to the water of the area, resulting to the rising of water level in the other parts of the world. Then we have also the ozone issue. I know you're familiar with ozone layer, which is found in the stratosphere. So the ozone layer absorbs ultraviolet radiation from the sun. So ito yung nakakatulong sa atin to prevent the UV coming from the sun. The worst UV coming from the sun. So it's like a cover. The ozone layer is essential to organisms because it protects them from harmful effects of the sun. And nowadays, the ozone layer is one of the major issues for our planet because there is what we call depletion of the ozone layer. And it was said human interventions make the depletion of ozone layer faster. What is ozone depletion? So if you are to define, or if you are familiar with ozone depletion, and how is it affecting our ecosystem? Do you think when there is depletion, there is also effect to our ecosystem? Of course, there is. There will be effects. For the reason that, sabi ko kanina, our systems, the Earth systems are interlinking with each other. what we call that, interacting with each other. Now, what is ozone first? Ozone is a highly reactive gas composed of the three oxygen atoms. There are only three molecules of ozone for every 10 million molecules of air. And what is this ozone layer? The ozone layer now is the deep layer of invisible gas in the stratosphere encircling the Earth that has large amounts of ozone in it. Meaning it's somewhat like a covering. So it covers the Earth from the UV light from the sun. Now, what is ozone depletion? Or ozone depletions, are they real? So due to human activity, as I've mentioned, sabi ko kanina, that ozone depletion was actually intervened by the human activities. So due to human activities, the ozone layer is getting weaker, causing a hole to appear and ultraviolet rays to enter into the Earth. Ito na yung nagiging problema because the ozone will cover the Earth to protect us from the UV, but because of the human interventions and activity, then the UV now appear and enter into the Earth. According to some scientists, it is not actually a hole, but a very thin layer with low quantities of ozone, and they discovered it in 1985. So, just think of it, 1985 pa nagsimula yung ozone depletion, meaning, in the present time, medyo malaki na talaga yung hole. However, there are studies saying that um, yung ozone natin is unti-unting lumabalik. There is what we call regeneration of the ozone. So that's a good thing. That's a good news that our ozone is now recovering. But of course, if we will not limit ourselves, if we will not do what is good for the environment, then there will be a continuation of the depletion of the ozone layer. Now, the causes of ozone depletion, of course, human interventions would have a great impact. Tao talaga may great impact in all aspects. So we have one of the causes, we have the chlorofluorocarbons or the CFCs. So chemical used to make refrigerators, home insulation, plastic foam, and throwaway food containers. So CFCs were discovered in 1930s by scientist Thomas Mitchell. So CFCs are non-toxic, non-flammable, and non-reactive with other chemical compounds. Why? Because it is or they are made up of chlorine, fluoride, and carbon. Now, bakit nagiging cause sila ng ozone depletion? So, sabi ko nga na too much is dangerous. So, too much chlorofluorocarbons is actually dangerous to ozone layer. It will result to the depletion of the ozone layer. So these are the percentages of the effects of the CFCs to the depletion of the ozone layer. So we have our refrigerators, lalo sa mga prions na tinatawag, 26% of that na nag-cause ng ozone depletion is coming from the refrigeration. We have also yung mga aerosols na tinatawag nila. And then we have foams, we have solvents, and then we have others. So in the illustration, you can see even your perfume, yung nasa parang pinipindot nyo when you like use your perfume. Then we have mga aerosols. So aerosol cans, yun yung mga ginaspray, mga anti-mosquito killer, yung mga Baygon nyo, those are actually aerosol cans. And then, of course, yun yung mga aerosols. Now, factors affecting temperature. So, temperature varies across the world because of the variations in the following factors. That's very true and observable. We have the latitude, the altitude,
the distance from the sea, the cloud cover, the winds, and the ocean currents. So these are some of the factors affecting the temperature. So any changes, or there will be changes in the following, then it will affect the temperatures of the earth. There are alterations, um, there are what we call alterations of every aspect or every factor with the result or would affect the entire earth as a system. So that's why we should save the environment, we should save the earth, because we can observe that nowadays our earth is now will now, or in the future, the earth will be lost. If we will not protect, we will not save and conserve our earth. So I guess that's the end of our discussion. I hope you are listening, and I hope, yeah, you are listening. You will listen to the recorded video in order for you to understand the earth systems, how the systems interact with each other, and how the interaction of the systems will affect life here on Earth. So thank you very much and have a good day.